Okay, so this is going to be a little interesting. I've been working on this for the last hour. I don't know what's going on with my Zoom, but anytime I do a video, it saves as an audio file. I did some research, configured out all that stuff. I, checked all my boxes. So we're going to do it this way with my phone. It's going to be a little wonky to read, but I hope by talking out loud, I can help you understand what I'm saying and all that stuff. Um, so yeah, okay, I'll also zoom in. That might make it easier. There we go. Okay, so the problem that I chose, 1 cup of coffee contains 643.82 milligrams of thiamine. I don't know how to pronounce that properly. Also, I have the hiccups, so that's why my voice is cutting out. Okay, so the formula for that is given is C12H14N4OS, which is carbon, hydrogen, nitrogen, oxygen, and sulfur. And it explains that the thiamine is a B vitamin that helps regulate your metabolism. So if you drink 1 cup of coffee, how many nitrogen atoms do you consume? So I reworded this problem so it'd be easier for me to understand, just based on the other example problems I did that were similar to this in the past. So my reworded version is, quote, how many atoms of nitrogen are in 643.82 milligrams of C12H17N4OS, aka thiamine, or thiamine, I don't know. Okay, why did I choose this problem? So I chose this problem because lately I have been consuming a lot of caffeine, coffee as well. And so it seemed like something that was more pertinent to my life. And I thought the stuff about the vitamin B was very interesting. So it just caught my eye. Okay, so now that we're going through the COAST stuff, collect and organize. What are you solving for? What should your units of your final answer be? So I put a word problem as well as some information. I'm solving to find the amount of nitrogen atoms that are consumed within 1 cup of coffee using the formula for thiamine. And the units of my final answer should be in milligrams, or never mind, sorry, I'll get to the milligram stuff later. My final answer, the units will be in atoms because we are solving for the number of atoms, which is a unit of measure. So the information I'm given the formula of thiamine, which is, as I said, carbon 12, hydrogen 17, nitrogen 4, oxygen, and sulfur. And then the amount of coffee added slash thiamine is 643.82 milligrams. And I did coffee slash thiamine because although it mentions that this is in 1 cup of coffee, which is the total amount, it's specifically asking us to find the nitrogen in the thiamine. So in a way, my brain sees this as one and the same, even though thiamine is part of what makes up the coffee. It just makes reading the beginning sentence a little simpler for me. And then based on what we see at the beginning, which this is our given amount, there's 5 significant figures. So there's 5 sig figs. Okay, so analyze. What information do I need? Just going through steps for this problem, I need the molar mass of thiamine. The molar mass in milligrams instead of grams, because when you find the molar mass of something, it's in grams over moles, and the initial measure that we're given is in milligrams. So it just makes it a lot less confusing if you convert the molar mass into milligrams, because or else when you're solving it, you'll have things in grams, you have things in milligrams, and then they don't actually multiply or add, or the math of it won't work, or it won't be correct at least. So that's a conversion factor, molar mass to grams, or molar mass in milligrams instead of grams. And then after that, we'll need to find the moles of thiamine, and then the ratio of nitrogen to moles of thiamine, and then the nitrogen moles to atoms. How will you connect this information you have and the information you need to solve this problem? So I did some bullet points and a sentence. I said I will use certain conversion factors and logic to provide myself with information needed to find the number of nitrogen atoms. I added logic here, although it's pretty broad, as just a way of representing like this idea that you need to actually analyze the problem, like realize that the starting amount is in milligrams and the molar mass when you solve it is in grams, and you need to critically think about that. Also things like diatomic molecules and all that stuff, or diatomic atoms, you know what I mean. So yeah, that's why I included logic there. And so in order to solve this, there's some things that are duplicates from my last section, but I just rewrote it again because I'm not exactly sure how to write out conversion factors on a Google or a Word document. You'll see my attempt at it later once I start solving, but for now, I just wrote it in words. So I need the molar mass of thymine, convert molar mass to milligrams a mole, find the moles of thymine using the molar mass and the starting amount, find the ratio of nitrogen to thymine, use ratio with the milligrams a mole of thymine and the ratio to find the moles of nitrogen. And then finally use a conversion factor to take those moles of nitrogen and convert it to nitrogen atoms, which is our final answer. Okay, so initially when I did this, I had the solve part blank and I did all the math and did typing while I did the video so you could see me work. But because, as I said, I've worked on this 5 times already, I don't want to rewrite again. So I'm just gonna explain the math that I did here. Okay, solve the problem, be sure to show all units and write clearly. Okay, so first we collect information. We have 1 cup is equal to 643.82 milligrams of thymine, and the thymine is this formula, the C12H17N4OS. And then we'll see here we'll find the molar mass of each of those things. So for carbon, take the molar mass of carbon and multiply that by 12, you get 144.12 grams per mole. You take the molar mass of hydrogen and you multiply that by 17, you get 17.17 grams per mole. And then you take nitrogen, the molar mass of nitrogen, and multiply that by 4, you get 56.04 grams per mole. And since there's only a single oxygen atom, you just use the molar mass of oxygen, which is 16 grams per mole. And then you have sulfur, and you have a single sulfur, so that's 32.07 grams per mole. And as I mentioned, you can see here, it's in grams per mole, not milligrams. That's an important thing to remember. And then you add all these together and you get the molar mass of thymine, which is 265.4 grams per mole. So now we want to take the grams and convert it into milligrams. So we set up a conversion factor. Once again, I know that this is a correct way of setting it up, but I can't read this very well because I don't associate the slash here as a division. It's just hard for me to read. So anyway, you start with the molar mass here that you just solved for, which is 265.4 grams per mole. And then you multiply that by the conversion factor, which is 1 milligram over 10 to the power of -3 grams. And this is because when you have a milligram, that is 10 to the 3rd grams. So it's not a full gram. Yeah, anyway. And what you'll see is that you have grams on top here, and you have grams on the bottom on this side of the conversion. And so the grams cancel out, and you end up with milligrams with moles underneath. And then when you multiply this together, in this case, I get 265.4, or not point, sorry, 265,400. And that's the answer for that. I left it as this answer because I wanted to show you the scientific notation. You remember that your decimal is at the end here. You move it 1, 2, 3, 4, 5 places to the left. So you get 2.654 times 10 to the power of 5 milligrams per mole. And the 5 here is positive because you're taking a big number and you're making it smaller. So that is the moles of, I'm gonna write that down, thymine. I think I'm actually spelling that wrong now, but okay, you get what I mean by that. Okay, so now what you do is you take the original amount that you were given. So you have 643.82 milligrams, which is again your initial amount of thymine, which is C12H17N4OS. Multiply that by 1 mole of thymine over 2.654 times 10 to the 5th power milligrams per mole, which is the molar mass of thymine. And in the end, what you get is 0.002425848. Now, obviously, this is not a pretty number. So we turn it into scientific notation. What we see here is you have the decimal and you move it 1, 2, 3 points to the right. So you end up with 2.425848 times 10 to the power of -3, and that's because you're making a small number bigger, and that's moles of thymine. So now you find the ratio of thymine to nitrogen. So when you have 1 mole of thymine, which is the entire equation, you'll find that there are 4 moles of nitrogen within it, which is, you can see right here, which is N4. And so you take this conversion factor that you found, and you take the answer that you just got for the moles of thymine, and you insert it. You have the 2.425848 times 10 to the power of -3 moles of thymine. I'll add that too. And then you multiply that by the conversion factor, which is 4 moles of nitrogen over 1 mole of thymine. And what you'll see is that since the mole of thymine here is on the top and the mole of thymine is on the bottom there, they cancel out, and you end up with moles of nitrogen. That's your final unit. And once you do that multiplication, you get 0.0097033392. And then once you put that into scientific notation, you move the decimal place 1, 2, 3 points to the right, and you get 9.703392 times 10 to the -3rd power. Once again, that's because you're taking a small number and you're making it bigger, and that's moles of nitrogen. That's your unit. Okay, so now all we have to do is take these moles of nitrogen, which is how many moles of nitrogen are in the given equation of the, the total amount of grams. So you take that number that you just got, which is 9.703392 times 10 to the power of 3 nitrogen moles, and you multiply that by the conversion factor of Avogadro's number of nitrogen atoms over 1 mole of nitrogen atoms. So the moles of nitrogen on the top and on the bottom cancel out, and you're left with N atoms. When you do the math for that, you get 58.433826662 times 10 to the 20th. Now, in this one, since they had such big numbers with the 10 to the 23rd, which is a lot of zeros or a lot of decimal places, I multiplied the first number, excluding the 10 to the power of whatever for each one. Multiply those together, you get this number, the 58, and then you take the 23 and the -3, and you put those together, and you get the 20. That's why it's 58.433826662 times 10 to the 20th power. Now what you'll see here is we have, this is in the wrong format for scientific notation, and you'll see that we need to move the decimal 1 place to the left. So you end up with 5.843382662 times 10 to the 21st. Once again, it's 21 plus 1, because we're making a big number into a smaller number. And now this is where the significant figures that we found at the very beginning of the equation, or the problem, come into play. And remember that we have 5 significant figures. This is easy here, so we don't have any zeros, so it's a lot easier for the rules to take place. It works better with my brain. So what we find out is when we narrow that down to 5 significant figures and write it in words, the answer is, in 643.82 milligrams of thymine, which is C12H17N4OS, there are approximately, or actually, I guess it's exactly 5.8434 times 10 to the 21st nitrogen atoms. So that's our final answer, or at least for that. It was nice coming back to this, because the first time I did this assignment, I didn't feel like I had enough information and was feeling pretty lost on how to solve these problems. But I was able to get it down to a simple step-by-step basis, and that helps me a lot. Okay, it helps me to organize my thoughts. Okay, final question. Think, does your answer make sense? How do you know? I'll just read, my answer makes sense because although my final answer is a large number, it takes a lot of atoms in order to weigh 1 milligram. I also double-checked my work and compared my procedure to other problems that I've worked on in the past and got correct. This goes back to Alex stuff, essentially practicing these problems and just writing them down on paper to help me organize my thoughts, and then going back and making sure that the steps that I took in this problem are correct. Also, my point of including this beginning part was because if you look at this number here, and if you have to add the 21 decimal places to this number, it's a big number. And when you compare that to this, you get a bigger number here than you have here. But the reason why that makes sense is because this is in milligrams and this is in atoms. And a lot of atoms go into 1 milligram, which obviously this is more than 1 milligram, which means that you have a lot of atoms over here. Because so that's my way of explaining why it makes sense. Besides the fact that I double checked my work and I compared it to the other work that I've done. So yeah, that's that. I hope this video was easy enough for you to read. Not sure why there's a Zoom problem. I'm gonna keep trying to figure it out, but this is what I've got. And if you need anything else from me, please let me know. Okay, bye-bye.